All right, I'm gonna wait for people to be ready in 5, 4, 3, 2, 1. You should have your module workbook out open to lesson 16. We're gonna just do what I think are the best parts of lesson 16 and lesson 17 because they have some really cool ways in the book of thinking about how the formulas for the circumference and the area of circles work and like why they work. So we'll look at those and we'll do some of the problems from the book, but not all of them. And then hopefully there'll be some time left over at the end of the period for you to work on some of your pie stamp activity stuff. Let's just do the basic worksheet stuff later in the period when that time comes and I give you some time to work on your pie week activities. Let's just stick to the worksheets, the basic stuff that's easy to do. If you're thinking about doing pie swag or a pie poster, or you want to paint some stuff, or you want to make a video or whatever, let's spend time doing that or talking about that when I come back tomorrow or on the block day. Let's keep it simple today, all right? So looking at lesson 16, it says, using a compass, draw a circle, like the picture to the right. So we're not getting compasses out or anything, but in case you have forgotten what a compass is, I wish I had one out. I should have grabbed one out. That's the thing that looks like this. Like you have a pointy end and then a pencil on the other end, and you can swing it around like this to make a circle. If you think about how those compasses work, that'll help you understand what I'm going to write here for part B. So if you think of C as the center of the circle, this point here, and then from C to B, this, we all already know that's a radius. And this point C and this radius are essentially what make up this circle. And we call it the circle centered at C with radius B. So what is the definition of the term circle? So if you ask just a regular person that, what is a circle? They would say, it's a shape, it's like round, and they'd probably try to make a circle in the air with their hands or something like that. The idea of like defining a circle is actually really hard. But from a mathematician's perspective, there's actually a very precise definition of what a circle is, and it's gonna sound weird and not make any sense when I first write it. So a circle is a collection. I guess I could have said a set of points, but I went with a collection. A collection of points equidistant. I bet this is a new word for probably everyone in the room. Equidistant just means equal distant. So if you and your friend are standing the exact same distance from a wall, then you and your friend are equidistant from that wall. So a circle is a collection of points equidistant from a central point, which we just call the center. So now if you go back and look at this circle up here, hold on, I'll wait a second for people to finish copying what I just wrote. All right, so if you look at this circle, C is the central point, and then all of these like billions, millions, trillions, infinite number of points that make up the circle here are all the same distance from C. This point here, whatever this point right here is the same distance from C as this point is over here, and this point over here is the same distance from C, and this point here is the same distance from C, and I could do this for the rest of my life until I die, many years from now. But the point is that if you made up all these points that are the same distance from C, and you kept doing this for infinitely long, you would eventually make the circle, right? And so that's really all the circle is. It's a collection of all the points that are the same distance from C. All right, so the next part says the length of segment A. Oh, sorry, I skipped this little thing here. It says to extend segment CB, so CB, the radius, they want us to extend it to another point A that is also on the circle. So they want us to make up some other point by extending this. So let's go from here to here. And so we call this point A. And now we just turned this radius into a diameter. And what they want us to see here is that the diameter is twice as long as the radius. So if you have a diameter and you need to know the radius, just divide it by 2. If you have the radius and you need to know how long the diameter is, just multiply it by 2. I think that's the main point of that. All right, let's turn the page. Here, they want us to do some stuff, but we're not going to do it. We're going to look at this, because I think this is pretty cool. This is one way of thinking about why the formula for the circumference of a circle, the circumference equals pi times the diameter. This is a cool way of thinking about why that is. So it says here the ratio of the circumference to its diameter for any circle, and that's not just circles in your math book or circles that you draw on paper, literally any circular object you see in the universe. So I'm just going to reach over here. So I grab this marker right just off the whiteboard just now, this circle right here on the end of this marker, the ratio between the diameter across and the circumference all the way around is pi. That's why pi is so cool, because it works for any circle in the universe. So the value of this ratio, circumference divided by diameter, is pi. So we write it like this: pi equals the circumference divided by the diameter for any circle. That's what pi is. And that's really the only way we have to express what pi actually is this ratio or this symbol. As soon as you start writing 3.1415926 blah, 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 you're just approximating pi. You're not saying the real pi. This is the only way to say the real pi. So if you think of a circle and any circular object in the entire universe, and you wrapped a rope all the way around it like this, then if you stretch that rope out, you took it and straightened it out, it would go across the diameter of that circle you started with exactly pi times, or in other words, 3 whole times, 1, 2, 3, and then that extra little bit here, 0.14159, blah, 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 blah. Well, and it turns out that this decimal here, 0.14159, is actually relatively close to 1/7. If I do 1 divided by 7 on this calculator, I get 142 something, which is pretty close to 141. And so a lot of people say you could represent pi, well, you could say 3.14159, whatever, but you could also just say 3 and a 7th is pretty close. It's not as close as the decimals that we memorize for fun, but it's reasonably close. Well, 3 and 1/7, that's the same thing as 7 times 3 is 21, plus 1 over there, it's 22/7. So if you wanted to do pi as a fraction, people use 22/7. If you want to do pi as a decimal, 3.1415, you guys know it. All right, so let's practice using that. Down here, for these exercises, they want us to find the circumference of these 3 circles, but they want us to use fractions. They want us to use 22/7 instead of 3.1415926. So let's try it one time. The diameter of this circle is 21, and I'm going to multiply that by the fraction 22/7. So pi times the diameter. I guess I'm writing it diameter times pi, but that doesn't really matter. And so I need to do 21 times 22 on top and 1 times 7 on the bottom. You guys should all have calculators in front of you, so go ahead and do 21 times 27, or sorry, 21 times 22 for me. It should come out to like 440 something, I'm guessing. I'll do it too. 462, I was kind of close. 462. Why did I write a 7? 462. And then we could figure out what that is as a mixed number if we wanted to, or as a decimal. Let's do that. Let's do 462 divided by 7. Oh, we get a nice even 66. So we're calling the circumference of this circle 66. All right, do the other two, please. Keeping in mind that they only gave you a radius here. You need to extend it to get a diameter. And I'll give you a couple minutes to do the other ones. And if you have extra time, you can skip forward to B. How about, and it's just 2 easy questions. How about a little over 2 minutes? There you go. I'm going to work them in that same time. All right, let's come back together in 3, 2, 1. All right, I'm gonna wait a few more seconds to quiet down, everybody to look up here. All right, so I was able to do the other two. I did 91/1 times 22/7, and I got 2002/7, and then when I divided 2002 by 7, I got exactly 286. They made all these nice so that they come out to whole numbers. That was nice of them. These usually don't come out to nice whole clean numbers like that. And then on the other one, I made sure to use 35 instead of 35/2 as my diameter, because if 35 divided by 2 is the radius, then twice that has to be the whole diameter, and what you're essentially doing is like 35/2, but then times 2, and that's 70/2, which is 35. So, or you could just think of it as like canceling out the same way we do equations. And so I did 35 times 22/7. I got 770/7, which when you divide that out, you get 110. So I'm writing C equals for each one of them because we're doing a circumference. So C just stands for circumference. All right, and then this last one, they say the radius of a paper plate is 11.7 centimeters. It'd be a big paper plate if it was meters. Find the circumference to the nearest tenth using 3.14. So now they want us to grab a calculator and use 3.14 instead of 22/7. And I just had a calculator. I don't know where I set it down. There it is. So first of all, if the radius equals 11.7, then the diameter equals 2 times whatever that is. And so I'm going to go ahead and use my calculator. Let's see here. I could do this in my head, but I'm just having fun. 2 times 11.7 equals 23.4. So the diameter is 23.4 centimeters. If I wanted to be super thorough, I'm just barely on the screen right now. And so the circumference equals 23.4 times 3.14. So 23.4 times 3.14, and we get 73.476. Oh, I said to round to the nearest tenth though, right? So that'd be, let's use the squiggly equal. I don't know if I've talked about this in class yet, but when we start approximating things with decimals of pi and stuff, since we don't really have the exact answer because we're approximating using an approximation of pi and we're rounding, then you can make a squiggly equal sign like this that kind of says, it's basically equal to this, but we're rounding or approximating. So this is 73.5-ish centimeters. All right, let's flip the page. Now it says the radius of the paper plate is 11.7 centimeters. Find the circumference to the nearest hundredth. Use the pi button on your calculator. I don't think our calculators have pi buttons, but we don't need pi buttons because everyone in this classroom knows pi to at least a few digits. So let's just try doing it a little bit further. So we know that r equals 11.7, and we already did it on the other page. That means the diameter equals, what was it, 23.4? 23.4. So this time we're going to do 23.4 times, you do however many digits you know that you can fit into the calculator. So I'm going to do times 3.1415926. I think that's probably as far as the calculator is going to let me go. And so it's 73.513. And if we round that to the nearest hundredth, that's where the 1 is. The 3 is too low, so we don't round the 1 up. So it's going to be C is approximately, because we're still approximating pi, even though we went to a lot of digits, 73.51 cm. So we didn't get that much of a difference between using all those digits and using just the 3.14. And I think that's the point of what they want you to see here, is that's why people generally just use 3.14, because even tacking on all these extra digits doesn't get you that much of a more different, more accurate answer. So 3.14 is good enough. All right, a circle has a radius of r centimeters and a circumference of c centimeters. Write a formula that expresses the value of c in terms of r and pi. We already know this formula. So in this class, you don't have to memorize a lot of equations or formulas. C equals pi times, well, Oh, they want it in terms of r? Oh, well, that's a little bit weird. So we know that the diameter equals 2 times the radius because it's twice as big. So we've been writing c equals pi times the diameter, but you can write it in terms of r too. You can go c equals, I guess it'd be pi times 2r, but we never write like no constant numbers like a 2 in front of a symbol like pi. So you're supposed to write it as 2 pi r. This means 2 times pi times r. But like I was saying, you don't have to memorize a lot of formulas or equations in this class. That's not really what math is about, memorizing stuff like that. But these ones you kind of do. There's a few equations or formulas that everybody kind of should know off the top of their head, and these are a couple of them. And when your next quiz comes up, you're going to have to know these off the top of your head to do well on that quiz. So please memorize. All right, the last one is they want you to find the perimeter of this semicircle. So you got to find this here, which is the circumference of half of a circle, but then you got to add that to this line here. I'll show you how to do it in a couple minutes, but I want you to give it a shot first. All right, use your calculator and use 3.14 for pi, and I'll give you, how about just 2 minutes to try it, and then I'll show you. Okay, we're coming back in 10 seconds. 5, 4, 3, 2, 1. All right, I'll wait a couple more seconds. All right, so first, let's find the half circumference here that I put in pink. So the way you do that is just find the circumference as if it were a whole circle, like as if it went like this. But then just divide that by 2 because you only have half the circle. So the diameter, we need to do pi times the diameter, right? That's circumference. And that is 3.14, so we're approximating. So I should use squiggly equals here now because I'm approximating. 3.14 times 8. Okay, so 3.14 times 8 gets me 25.12. And then I want to divide that by 2 because I only need half of the circumference here. So 25.12 divided by 2 equals 12.56. So the pink part here, not counting this part, this was just like for demonstration. Now it's starting to look like a guy wearing a beanie with like a scraggly beard. But anyways, this part up here is 12.56, and then we just add this to this 8 right here. So plus 8, and we get 20.56 meters. If your question gives you a unit like meters, feet, centimeters, or whatever, always put that unit on the on your final answer. You don't have to put it in all your calculations though. And also I realized that I did something up here that I hate and I want you to never do. I didn't write out my calculation here. I just put the answer that I got from the calculator. Oh, I hate that so much. Write what you put into the calculator. So what we should have done here is written that we did 23.4 times 3.1415926, I think is what I put in the calculator, and that equaled that 73.51. Please always do that. It drive me nuts if you just put the answer on your worksheets and on your homework and on your papers, whatever, especially on a quiz. All right, let's fast forward to lesson 17. Lesson 16 will be your homework, and I think I made the last two questions challenge. Those are like optional. Let's see here. Lesson 17. All right, so lesson 17 is more about the area of a circle, and they start off by just asking us to remember how to find the area of a rectangle. So remember the area, that's when like you fill in the whole thing, right? Not just going around the edges, but the whole thing on the inside. And so if you want to know the area of this rectangle, you would just do 6 centimeters. I know I just said you don't have to put the units in your calculations, but I'm doing it here for a very specific reason. Times 4 centimeters equals 24 centimeters squared. See, I get the centimeters squared from the fact that I'm doing centimeters times centimeters. And this 2 right here kind of tells me that this is a 2D measurement. That was a terrible place to write that. But so instead of just one dimension, like length going around, which is what circumference is, now we're talking about 2 dimensions, right? We're filling up a whole area or a space. So width times length, or length times width, or whatever you like to call it, but that's how you find the area of a rectangle, width times length. And that's going to be important for this thing that I want to show you on the next page. So we are now on page 220. So we know from yesterday and just from whenever that the area of a circle equals pi times the radius squared. And this means to do radius times radius. And this page right here is meant to be a way of thinking about why that's true. And I don't know, I really like it. So I want you guys to try to follow along with this. They said, pretend you got this circle and you cut it up into a lot of slices, essentially like a pizza, right? It looks like a pizza that they've cut into 1, 2, 3, 4, 5, 6, 7, 8, 16 total slices. This example or this like thing that they're trying to show you here actually works better the more slices you cut your pizza into. If you can cut them super duper skinny, so they were like a molecule wide, and so you had like billions or trillions of them, then this diagram works really perfectly, but it works well enough with 16 slices. So cut 16 slices and keep 8 of them shaded like this, and the other 8 just like not shaded, so you can kind of tell them apart is the point of half of them being shaded and half of them not. And then imagine that you cut the slices open and you fanned them out. Like you open the top half so it looked like this, right? Imagine sort of like this motion. And then you did the same thing to the bottom. And now you can interlock them together like this. Well, when you interlock them together, if you take this end piece here and sort of cut it in half, and then slide 1/2 of that end piece over here so it fills in this empty spot here, the whole thing interlocks and makes a pretty good rectangle. It's not perfect rectangle because like the top is a little bumpy, right? Like it's not perfectly straight. Well, if you cut this thing into 1 billion slices instead of 16 slices, then this top starts to become super straight instead of bumpy. And now they're saying, look at where these pieces come from. This circle got made into a rectangle, and this side right here is the same as this right here, which is a radius of the circle. So that's why they put radius here, and it's essentially r. Well, they put it here. It's an r. And then this here that I was starting to shade across the top in blue, right, this whole distance here, well, that's the whole outer edge of the shaded slices. So it's like your whole crust region, if this is a pizza here, of this part here. but that's half of a circumference. And remember, we wrote on a previous page that the circumference equals 2 times pi times r. But that means that half of a circumference, which I could write as half c, has to equal just pi times r, because I'm just dividing the whole thing by 2, which gets rid of that 2, just like when we solve equations. So half of a circumference is just pi times r, which that's what they've written here, pi times r, right? And I'll write it here, pi times r. And then since it's a rectangle, if we wanted to find the area of this thing, we would do height, which in this case is r, or length or width, whatever you want to call it, times, I guess I would call this the width, pi times r. So you get pi times r times r for the area of this rectangle that's made up of what used to be a circle. Well, pi times r is just pi r squared. And so I don't know, I just think that's a cool way of thinking about why that formula works. All right, so let's do like one question where we got to do some pi r squared stuff, and then let's work on pi stamp stuff for the rest of the period. Actually, no, I lied. I'm gonna do one question, and then I want to challenge you with this one down here because I think this one's cool. I'll make this fast. It says a sprinkler rotates in a circular pattern and sprays water over a distance of 12 feet. So you've got this like sprinkler in the middle of the lawn, and it's spraying water. So let me use blue for the water. Have you ever seen these sprinklers that go as they come around and then they come back? It's one of those. And so it's spraying 12 feet, but it's going all the way around in a circle. I'm really terrible at drawing circles at the beginning of Pi Week, but then as we do this more, I get better. So this is a terrible circle with radius 12 feet, and they want to know how much like area of lawn is the whole thing covered. So let's just do area equals pi times the radius squared, which means we got to do, we'll use 3.14. So that's why I use squigglies now, because I'm writing 3.14 instead of pi. And then times 12, and then, so we're squaring the 12, so we can write it as 12 squared. You always do the squaring of the radius first. PEMDAS, right? PEMDAS says you got to do your exponents first before you multiply. So you always, always, always square the radius first, then multiply by 3.14. So 12 times 12, we do that part first. We get 144, and then we times that by 3.14. You're kidding me? All right, 144 times 3. What? Oh, geez, I'm falling apart here. Let's do it one more time. 144 times 3.14 equals 452.16. So the area of this thing is squiggly 452.16 feet squared. Because we're doing area, it's a two-dimensional measurement, so we get feet squared. All right, I want you to try this question for a couple minutes before I say, okay, do pi stuff for the rest of the period. I'm gonna draw a diagram here to help you though. Essentially what the question's saying is he's got this piece of wood that's a square. It's green wood for some reason. And the square is, the radius of the circle is cutting 3 feet. So I think the area of the square is supposed to be the same as, or I'm sorry, the side of the square is also supposed to be double the radius. So pretend that this side here is 6 feet, and that the circle she's cutting out, it has a radius of 3 feet, which means it has a diameter of 6 feet. All right, so it's essentially this circle here. It's just barely going to touch the edges of the square. So this is 3 feet. And so now they want you to imagine they're cutting this circle out, and you have to figure out what is the area of all this stuff, the leftover kind of rounded triangle chunks that are going to be wasted from this project. That's what they want you to find the area of. All right, work on that for a couple minutes. I'll show you the answer, and then you can have the rest of the period to work on your pi stuff. All right, we're coming back together in 15 seconds. 5, 4, 3, 2, 1. All right, so I imagine some of you might have been confused on that one. You kind of have to think logically or kind of come up with a trick here. What you do is you find the area of the square, then find the area of the circle, and then subtract the circle from the square, because that's kind of what you're doing in real life, right? Like by cutting this circle out of the square, it's like you're subtracting it from the square. And so if you have the area of the square minus the area of the circle, what's left must be the area of the blue shaded parts. So the area of the square, this is something mathematicians do here, is when they know they're going to have multiple a's in their work, because they're going to find the area of a square and the area of a circle, is they'll write a big A and then square in small letters underneath it to show that, oh, that's the area of the square. And so that's easy. That's just 6 times 6, which is 36. And then the area of the circle, that's, well, let's squiggly it, because we're going to use 3.14 times 3 squared. And we know that 3 squared is 9. That's an easy one. 3 times 3 is 9. I hope you didn't think it was 6. That's a common mistake, as students think that squaring means to multiply by 2, and then they do 3 times 2 or whatever. Squaring means to multiply by itself. So 3 times 3 is 9. So what we got to do is 3.14 times 9. That should come out to like 28 something, I think. Usually I start to have these memorized after a while. 3.14 times 9, 28.26. That sounds familiar. So I'll write it right here, 28.26. And then we just do area of the square minus area of the circle, and we have those little leftover pieces, the area of those. So area of, I don't know, I'm going to call it leftover. Or maybe I should use the word waste, because that's the word they use in the thing. I'm writing leftover. Leftover. That's going to be 36 minus 28.26. And I believe that is 7.74 feet squared, right? Okay, so for the rest of the period, you can work on worksheets to get your pi stamps. I believe I'll have them set out here at the front of the class. You might already just have them from grabbing them yesterday or whatever. Let's not make a mess. If you're grabbing sheets from the stacks up here, keep the stacks neat. There's no reason why it should turn into a big old mess. Save anything you complete. I'll stamp them when I come back tomorrow. And yeah, I think that's about it. All right, I'll see you guys.